Welcome to today's video, which covers the first part of Section 4, Complex Numbers. We have three objectives for today's video. We are going to simplify imaginary numbers, we are going to perform operations with imaginary numbers, and then we are going to perform operations with complex numbers. Today's video is no calculator, but you will need a calculator for the first review question. After this question, you can put away your calculator. So the review question says, graph the equation y equals x squared plus 2x plus 4 in your calculator. How many real roots does this quadratic have? So remember, to graph, you're going to have to go to y equals and put in your equation. And then you're going to have to hit zoom standard, which is zoom 6. So right now, pause the video and graph this in your calculator, please. Now, if you did that correctly, this is the graph that you should have gotten. So the question is, how many real roots does this quadratic have? Well, a real root happens anytime the quadratic crosses the x-axis. This quadratic doesn't cross the x-axis, so it has 0 real roots. Okay. A root comes anytime that you set your equation equal to 0. So if I were to set this quadratic equal to 0, x squared means I should have 2 solutions. Well, if I have no real solutions, then what type of solutions do I have? That's where this section comes into play. So this section is going to introduce imaginary and complex solutions. So we're going to look at quadratics that don't cross the x-axis, and we're going to find the imaginary or complex solutions that they have. Before we do that, though, we need to introduce imaginary numbers. Okay, so imaginary numbers use the imaginary unit I. I is defined as I squared equals -1. Therefore, I is the square root of -1. Now, in the past, anytime you end up with a negative under the square root, you're told that that's not a solution that we use. That's because negatives under the square root are imaginary numbers. They're not real numbers. So looking at example number 1, we have an imaginary number. It's the square root of -45. So we need to simplify this. The first thing that we're going to do is take that negative out. So -45 is just -1 times 45. Now I know how to simplify the square root of 45. The square root of 45 is root 9 and root 5. Root 9 is root 3 and root 3. So this gives me a pair of 3's. One of the 3's comes out. The 5 that doesn't have a partner, so this 5 stays under the root. Now, what do I do with that square root of -1? Well, I just told you the square root of -1 is I. So this becomes an I. So my answer is 3I root 5. So let's look at the next one. Square root of -20. That's -1 and 20. Now 20 is 4 times 5. 4 is 2 times 2. So I have a pair of 2's. 1 2 comes out. That lone 5 stays under the root. Now again, this square root of -1 becomes an I. So my answer is really 2I root 5. Okay, let's have you try an example now. So I would like you to try this example with the stop sign. Pause the video and try this one on your own, please. Come back when you are finished. Okay, let's see how we did. The first thing I would have done is multiply the 6 and the -15. That gives me the square root of -90. Now you should have simplified. -90 is -1 times 90. The square root of -1 is I. 90 is 9 times 10. 9 is 3 times 3, which is a pair. 10 is 5 times 2, which is not a pair. One of those 3's comes outside. The 5 and the 2 become 10 under the root, and then I have an I. So you should have gotten 3I root 10. If you didn't, make sure that you go back and fix your work. If you did, good job. A few properties. So that's here to the left. I is the square root of -1, and I squared equals -1. We're going to use these two properties on the next page. Before we move on, though, do you know what is the only state in the continental U.S. that borders only one state? So by continental U.S., I don't mean Alaska or Hawaii. So which is the only state that borders one state? Flip the page and we'll return to the answer. Okay, so example number 2 says simplify the following. We have I to the 44th. Now I know that I squared is -1, but what's I to the 44th? Well, what I want you to do is rewrite I to the 44th in terms of I squared. So what you're going to do is you're going to divide that 44 by 2, which is 22. So this is really I squared to the 22nd power. So 2 times 22 is 44. Now I squared is -1. So really this is just -1 to the 22nd power. -1 to an even power is +1. For this next example, I'm going to start you out. So again, I have I to the 63rd, and I'm going to divide it by 2. This time 63 does not divide evenly by 2. 62 divided by 2 is 31, and I have a remainder of 1. That means I have I squared to the 31st power, and I have an extra I. Right now, pause the video and see if you can finish this on your own, please. Okay, let's see how we did. Now I squared we know is -1. So this is -1 to the 31st power times I. -1 to an odd power is -1. So this is -1 times I, which is just -I. If you got that right, good job. If not, that's okay. You're going to have time to practice it tomorrow. So we have one more operation that we're going to do with imaginary numbers, and that's example 3, multiplying. So I have -5i multiplied by 3i. -5 times 3 is -15. I times I is I squared. So I have -15i squared. Can't leave I squared though. I squared is -1. So this is -15 times -1, which is just +15. Right now, I would like you to pause the video and try this one with the stop sign on your own, please. Complete the problem and then come back when you are finished. Okay, let's see how we did. Now 3 times 4 is going to give me 12. I and I to the 3rd is I to the 4th. Now if I divide 4 by 2, I get 2. So I have I squared squared. I squared is -1. So I have -1 squared times 12. -1 squared is +1, and I'm multiplying by 12. 12 times +1 is +12. Hopefully you got that. If you made a mistake, that's okay. We again will practice some more tomorrow. So that's imaginary numbers. Imaginary numbers are leading us into complex numbers. So a complex number is written as a plus bi. A is called the real part. B is called the imaginary part because it has the I. So right now, we're going to perform operations with complex numbers. So we're going to add, subtract, multiply, divide complex numbers. So looking at example number 4, we are the example to the left. We are going to be adding 2 complex numbers. Now you can add the real part. So 5 add 2 is going to be 7, and then you add the imaginary parts. -7 add 4 is -3i. And that's my final answer. Right now, pause the video and try the subtraction example, please. Let's see how we did. You should have subtracted the real parts. So 4 subtract 3 is 1. And then subtracted the negative parts. -8 subtract -6, that's like adding a 6, that's -2i. Now, that one was definitely more difficult. My suggestion would be to distribute the negative. So that's 4 minus 8i minus 3 plus 6i. I would distribute the negative so that you don't mess up your signs. If you can do it in your head though, that's fine. Now, we only have 2 more examples, so stick with me. Before we get to those examples though, I want to answer the trivia question from the previous page. So the question was, what is the only state in the continental US that borders only one other state? So looking at our map here of the United States, the answer is Maine. Maine is the only state that borders only one other state, and in this case it borders New Hampshire. So if you got that right, awesome, good for you, you're so smart. If not, maybe you're not very good at geography like me. I would like to say thank you to Owl and Mouse Software who gave me this picture. Okay, we got one other example that we're going to do. Okay, so looking at example 5, now we are going to multiply. So when you're multiplying complex numbers, you don't just get to multiply the real and the imaginary parts. It's kind of like multiplying binomials. So if you remember multiplying x minus 2, x plus 4, something like this, some of you FOIL, I do the box. So that's what I'm going to do. I have 5 and negative 7i. I have 2 and positive 4i. 5 times 2 is 10. 2 times negative 7i is negative 14i. 5 and 4i is 20i. And then I have negative 28i squared. So this gives me 10 plus 6i, because negative 14 and positive 20 is positive 6, minus 28i squared. Now you can't leave your answer like this. Like above, you have to substitute for that I squared. So I squared is negative 1. So this is really positive 28. 28 add 10 is 38. So you get 38 plus 6i. Okay, the last example is yours to do on your own. Now I'm going to help you out. Please do not distribute that squared. Remember that squaring something means multiplying by itself. So, right now, do that last example. When you come to class tomorrow, we will be checking to make sure you have all the notes and all the examples completed. Please remember to remind your teacher to go over this last example. See you tomorrow.